Now let's look at the next topic. We're going to talk about the circular motion. So first, let's look at some questions to review some fundamental concepts. Okay. Question 1. If a particle moves with a constant speed but changing direction, constant speed but changing direction, okay? What is the acceleration of the particle? A, 0, B, non-zero, C, cannot be determined. Okay, in this case, what's that?
C.
C, okay. Anything else?
B.
B, non-zero. Anyone would say A. Okay, so first, A is definitely wrong.
Oh,
So please note that I emphasize constant speed,
has
not the constant velocity.
triple constant.
If a motion with constant velocity, you know that the acceleration has to be 0. Okay? But constant velocity means both the magnitude, the speed, and the direction should be a constant. And here I say that since it's constant speed but changing direction, so you must to have some acceleration to change the direction. Okay. The acceleration is needed to change both the magnitude, either the magnitude or direction. Okay. So constant speed motion with changing direction, you do require some non-zero acceleration. So the answer is B. In this case, since I say that the direction is changing, you can determine it has to be non-zero. Okay? This knows the constant. Question 2. Okay, of course, now it's review. If a particle moves with a constant velocity, what is the acceleration?
0.
A. Okay, 0. Now, question 3. If the acceleration is in the same direction of the velocity, which of the following will change the direction of the velocity or magnitude of the velocity of both? Magnitude, okay. If the acceleration is in the direction of the velocity, so it will change only the magnitude. Okay. So you can even also think about in terms of force, because acceleration is proportional to force. If the force is in the direction of the motion, it wouldn't change the direction. Okay. Similarly, what happened to this? If the acceleration is perpendicular to the direction of the velocity, which will be changed? Direction, the magnitude, or both?
Just the direction. A.
Just the direction. If some acceleration, some force perpendicular to the direction of the velocity, it will only change the direction of the velocity, put it this way, but not the magnitude. To change the magnitude, you have to be the same, or at least have some component in the same direction of the velocity, so you can accelerate or decelerate it. Okay. So these are trying to emphasize some aspect of velocity and acceleration vector. Okay, vector nature is always the most important and also most tricky part of the physics. Any question here? So if you understand these things, so you will have a clear picture of the uniform circular motion. The motion we are going to talk about. Okay. So uniform circular motion is moving with a constant speed around the circle. Okay. So the reason I want to ask you those questions is try to avoid some misconception. Okay. The common misconception is that because it's called uniform, and we know it's talking about that the speed is a constant. So you may tend to think that there is no acceleration. But for any circular motion, you do have non-zero acceleration. Because you can look at the velocity. The velocity here is in this direction, this direction, this direction. So velocity always change direction. Okay, so that means you have to give it some acceleration to change the direction. This acceleration is called the centripetal acceleration. Okay. So here, if you look at this graph, the centripetal acceleration is called centripetal because always pointing to the center. This is acceleration, 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 acceleration. Okay. So centripetal acceleration always radial, inward, and so it's perpendicular to the velocity. Velocity always in the tangent direction. And we know that if the acceleration is always perpendicular to the velocity at any time, it's always perpendicular at any time. So it will never change the magnitude of the velocity, right? So that's why it can maintain a constant speed. So this is quite a spatial motion that at any time the acceleration is perpendicular to the velocity, so it will never accelerate or decelerate it in terms of the magnitude. Okay. So please note that we have the projectile motion. Initially, the acceleration is in this direction. If we're talking about the horizontal projectile motion, the velocity in this direction. So at this point, it's very similar to circular motion. But after that, please note, after some later time, the velocity becomes this in this direction, right? At this point. But the acceleration is still in this direction. So now it's not perpendicular anymore. So it has both the perpendicular component and the parallel component to the velocity. So this one, finally, it will not form the circular motion. Okay. And this is because the acceleration is constant. It can always point into one direction, but velocity will change direction. So they are perpendicular only at the initial time. And in this case, the acceleration is not constant. Please note this is not constant acceleration. Okay. Magnitude is constant, but the acceleration is also change direction all the time. So it can maintain the perpendicular relationship with the velocity at any time. Okay. So this is uniform circular motion. If the acceleration is not exactly perpendicular to the motion velocity, you can still possibly have the circular motion, but it will be non-uniform circular motion. Okay. Another thing I would like to introduce is the period and the frequency of the circular motion. Okay, circular motion is some repeated motion. Okay, so it will one revolution, another revolution, like that. So it will be good for this kind of repeated motion. It will be good to introduce some quantity to characterize each revolution. Okay, we want to know how much time take to finish one revolution. This is called the period. Okay, we use capital T. It equals to 2 pi r over v. V is the uniform constant speed of the circular motion. And this one is very straightforward to get. Think about how can you calculate the speed of a circular motion if it's uniform. It should be the length of the circumference, which is 2 pi r, divided by the time to finish one revolution. By definition, it's the period, right? The period equals to 2 pi r over v. Okay? And the frequency is actually the inverse of the period. It has a unit. Period, of course, unit is standard unit, second is time. This is called hertz, or 1/2 second. Okay. And The physical meaning of the frequency is that it measures a period, to finish one revolution, how much time you need. Okay. And frequency actually measures for each second how many revolutions you are going to finish. Okay, it's inverse to the period. Okay, I guess we have to stop. Do you have any question?